Okay, so today's uh, GFG problem of the day is word search, which is a really nice problem and has been asked in multiple companies. So yeah, so the problem basically states that we have a matrix. Okay, so we have been given this matrix, and what we have to do is we have been given one word. So we need to find whether the given word exists in the matrix and in the sequential order. So let me give you one example. Yeah. So here the word we are looking for is loop. Okay. Now, yes. Now, what we have to do is like here G exists. Okay. So what we need to do is we need to find the next character, whatever it is, in its adjacent nodes. Okay. Like the next character cannot be this. Like if E was present here, we will not be technically considering that. Okay. We will only consider a character if it is adjacent. I mean, in the question, adjacent defines we need to look in the four directions: top, bottom, right, left. Okay. So these are the only four directions we're concerned with. So now here, if you see, we have E at two places. Okay. We have this E and we have this E. So we need to take care of both the E's, and then when we enter a E, we again have to look for the next character, which is again E in its adjacent nodes. Okay. So that's the idea. Now, Uh, okay, so we will be using DFS to solve the problem. But before that, let me just tell you I tried solving it using DFS, but I was unsuccessful because in DFS what happens? Suppose you start with G. Okay, now we will find two E's, right? So DFS is not. So in DFS, what happens is we explore all the levels. So from G we have two E's, right? So like we'll go to this as well, and we'll go to this as well. Now, what does BFS do is BFS will now explore this level and this level, right? But what essentially we need to do is we need to, you know, we need a definite path. So we need to completely iterate across one of the possible branches. So suppose in DFS, what happens is suppose we get this G and now we get two E's, right? So the G, so the DFS path will be to go down or to explore this path in depth. Once we explore it, will explore it sequentially. So that will give us a valuable answer. But if we go for breadth first search and we explore this and then we explore all this path, we are losing the sequence, right? Because we are losing the sequence here. This is not a correct sequence. So yeah, DFS will not work in this scenario. DFS will occur. So how will DFS work? It's really simple. We only need to know the basic implementation of DFS, and if we know that, we should be able to work it out. The only addition here is we need to keep track of the index. We need to take some index which will keep track of the current character we are at. Okay, and once this index is exceeds the word length, then that's when we know that okay, we have found the correct we have found the valued sequence and we have found the word on the matrix and we can return true. So I'll take you through my code. So yeah, we are okay. Yes. So here we are taking care of the rows and number of rows and number of columns. Now I am taking this vector because it might happen that we have multiple G's. What if I have another G over here? So we are not starting. For DFS, we need a starting node, right? We need to start our iteration from some node. So when we're starting, we can have multiple starting points. We can have multiple starting points. So to keep track of all the starting points possible, what I'm doing is I'm keeping track of a vector. In other cases, this might just have been one integer, okay, not a vector. So here what I'm doing is I'm checking if see the first character has to exist. If it doesn't exist, we will automatically return false. But if it exists, we will have a vector with the so in this scenario, the vector will hold 1 comma 1. But suppose if T was present in some other cell as well, then that will also be present. Suppose if G was present somewhere here, then this value will also be present on the vector. Only one is present. Okay. Now, yeah. So this IDX we are taking to track the word. So now for all the starting for all the positions where we have the starting, character of the word, I am writing this. Okay. And this is our visitor. Now this is a very important thing. I had one failed submission because I was using one. So basically, I initialized visited here. So if we initialize visited here, it means the same visited matrix will work for all the starting nodes, which is incorrect. For every starting node, we are doing one separate DFS iteration, right? So for every node, we need to have for every starting node, we need to have its own visited matrix. So that's what I've done here. And yeah, from there it starts a DFS iteration. So the only points which are changing is this is the row, this is the column, and this is the index. The other things are static. Okay, they're not changing much. Yeah, now let's look at the DFS. And okay, we can only travel in the four directions. So that's what I've taken care of using these vectors. Now, as soon as I suppose I'm at G, I have to mark it true, right? I do not want to visit G again because if from G I go to E, then from E again I can come to G, right? I have to mark it as visited. And now I'm done with the zeroth index, which was G. Now I have to take care of E, which is the first index. So I have to keep on incrementing the index. And when suppose we reach K, so the index will automatically be equal to word dot size, and that's when we know that okay, we have found a correct sequence. Otherwise, we have this, we are just iterating through all the adjacent nodes possible, calculating the new column, checking if the new row and the new column value which we are finding is valid because we might, exceed the or exceed the edges and go beyond the boundaries. If it is not visited, obviously, and this is another condition. So this is up to this we have this usual TFS algorithm. This is specific to this problem where we are checking that we will only visit a node. See, I from G, the only two places where I should visit is the top E and the bottom E. K and S are of no use to me from this G, right? So I only visit this if the word index. So index we incremented here. So the index is now pointing to 1. So if this 1 matches E, only then we will move to this and calculate DFS from there. And that's exactly what we did, and we're calculating DFS somewhere. So from DFS we get it to return true and return false. Not a tough problem. It only uses our basic idea of DFS algorithm. So it's the medium is the bit difficulty waiting for it. Yeah, that's it. I think. That will be it for this video and for this problem explanation. Thanks.